Okay, so now I am going to be taking you through an introduction related to the trigonometric functions, whereby there is an involvement of horizontal shift. Horizontal shift. Trust me, the honorable member, when I say these graphs work exactly like the other graphs that we have studied before with regards to the left and right shift. It's just confusing, or it may be confusing, but trust me when I say not that much difficult. As long as you've done all the introductory lessons on this topic, where we started with the basics of grade 10. There is no way you will not understand how these functions work, because the foundation is based on all that we have done in the introduction of the grade 10 lessons, and also all that we did when we were solving exam question paper. So this lesson, it is a continuation of those. In other words, you cannot start from this lesson, or you cannot do this lesson without having done all of those lessons, because in this lesson, I will only be touching or emphasizing the new things, or things that you are supposed to be learning for the first time. Definitely, horizontal shift is what I'm going to be talking about. So we've got obviously the functions for sine, cos, and tan. And we have seen how these functions can shift up and down, where they are influenced by when you add the q value. Maybe it's an x plus q, or cos x plus, they can use c, or tan x plus, it doesn't really matter that much in terms of what letter they used. Even if they use letter p, it doesn't really matter that much. So that q value can be plus or a minus, c plus or a minus, just like p can be a plus or a minus. Whereby a plus would mean a shift upward, and then a minus would mean a shift downwards. So on the Cartesian plane, the function maybe does that. It will be shifting downwards or upwards. That's how the vertical shift works. So this time around, we are now looking at the left and right shift, which means it may now do something like that. Can you see? Still within the same range. The range doesn't change. It is still within the same range. It's just that now it starts just a bit towards the right. Can you see? So it is that same thing. It's just that now there is that shift of maybe by 30 degrees, or it could be 60, whatever the case may be. Or it can be shifted towards the left, and then it starts by 30, 60, 45, it doesn't really matter that much, but towards the left. So that means we can have the shift in the left or shift towards the right. Once you are done with finding out the value of the shift, then everything else that you do, it is the same as what you already know. So the shifted function has a general formula that looks like this. So it would be y being equals to, let's say, sine, in the brackets you've got x, and then we can say plus p. That is how a shifted function looks like. And then for one of cos of an angle, then we will have x there plus p. And then the other one for tan, it means it would be a tan of x plus p. Remember that value of p, it can be plus or a minus. It can be plus or a minus. So the plus or a minus it is the one that will help us to calculate the value of the shift and also the direction of the shift. How you calculate the value of the shift and the direction, you take the whole of that, you equate it to 0, and then you solve for x. The whole of that, you take it to 0, then you equate it to x. The final answer, it will then be telling you by how many degrees and the direction, whereby you will find that positive will mean towards the right, a shift towards the right, and negative will mean a shift towards the left. Definitely, it will make sense the moment we start doing some sketching. I would like for us to start sketching. But perhaps we do the sketching. Let me maybe give you an idea of what I'm talking about when I say the shift. I'm now thinking as to whether I should show you the calculation of the shift, or perhaps plot it first and thereafter, after plotting it, we interpret it, and then from there we come up with the formula for calculating the shift, or I teach you how you calculate the shift. I think that would be the best approach, just so that you are not confused in terms of what is it that we are talking about when we say the shift. Let's maybe plot these two functions. Let's plot the one of y, which is equals to, maybe let me start on a new blank page there. I want to make sure not to rush this. So we plot y, it's equals to, let's say, sine x. And this one, we plot it for x being the element of 0 degrees and 360 degrees. And what I would like for us to do, it is to plot that same function, but this time around we shift it. We will shift it by a certain amount of units. Let's just say we plus it by 30 degrees there. And this one is for where x is the element of, maybe let's do it like this, negative 30 degrees there, and then we will say 330 degrees. So we need to now plot these two functions on the same set of axes. So this is exactly what I would like for us to do. So look at this. Maybe let's start with that first one. What we know is that when it comes to that first one, we will definitely need to have that horizontal line. So that means the most important thing when it comes to sketching these functions is for you to find out what are the critical points. So let's say there we are having that one, -1 there. Maybe this side there, definitely 0. So 1 and then -1. And what else? Starting with that first one, how do we find the critical values? We said critical values, it will be the period, of which the period for that one is 360. You know how to calculate the period most. Then we are going to divide it by 4. And after dividing it by 4, we get our critical points, which is from 0, it's going to increase by intervals of 90. So that means we can have 90 there, and then we add another 90, it becomes that, another 90 there, it becomes that, and then another 90 there becomes that. Even though the spacing is not enough, let me just improve that and be more realistic and say, let's say from 0 spaced by 90, space by another 90, 90, and then 90. Then on this other side, it doesn't really matter that much. I've extended it because there is another function that is going to shift. So that's why I've extended it. But it's fine. I will just say on that other side, it's negative 90. So, okay, let me just write it down and say 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So this one would be negative 90 degrees. Can you see? That is y-axis and that being the x-axis. So can you now see? I've already worked out. I have already worked out the critical points for that first function. So when you look at the second function, it is still that same function of sine. It's just that it has shifted by 30 degrees. So now it becomes a question as to whether it has shifted by 30 degrees towards the right or towards the left. I think this is where now I need to teach you how you know if the graph has shifted towards the left or towards the right. So we go back to what I've just explained, where I said you will take this thing inside to equate it to 0, then you solve for x. So that means you take that x plus 30 degrees, you equate it to 0, and then when you solve for x, you will say, if you take 30 to the other side, it becomes negative 30 degrees. So that means it has shifted by 30 units. That negative sign, it simply means towards which direction? Towards the left. So that's how it works. Negative towards the left, positive towards the right. So let me just add there to say, if we had something like y, let's say cos into x, maybe let's say negative 45 degrees there. So that means it becomes x minus 45 degrees, you equate it to 0, x equals to positive 45 degrees. So that means it has shifted by 45 degrees towards the right. So it is 45 degrees shift towards the right. So in other words, for this function, it does not start from 0, but it starts from 45. On the Cartesian plane, it starts from 45. Then how do you know the next value that you should put there? That's when you continue by increasing with your critical value. That value of the critical point, you keep on increasing by that. This one, it just tells you where to start and then increase by the critical point or the critical value, of which the critical value still use that same formula for the period divided by 4. So that means for this function, it would be again 90 degrees. So that means shifting by 45, you start from 45 and then you keep on adding by 90, 90, 90, until that range where they said x is the element of whatever and whatever. So let's go back to this one. It means by now we have seen that it has actually shifted by 30 units to the left. Okay, so if it has shifted by that to the left, let me then show you how you will therefore derive your critical values. Remember, for you to get to 90, that means there must be 30, 60, and then 90 there. So this one, it has shifted by 30 units to the left. So that means it is going to start from there. And then we have 0, 30, 60, 90, is it 120, 150, 180? So that means in between you have 2 points, because you are now trying to space it by make sure that that interval of 30 is included. So now let's see. That means since it has shifted, it will be that negative 30 Then to get your next critical point from that negative 30, you just add by that 90. So it takes you to positive 60. That is your next critical point. You plus it by 90 again, you get to 150. That is your next critical point. You plus it by that, you get to your next critical point. You get to 330, that is your next critical point. So can you see, even if you label these other points, it is still fine. But what we know is that the most important points are these ones that are spaced at 90 from that value. What is this one? Is it 210? Yes, it's 210 degrees. This one, what would it be? 270 plus 30, is it 300? Yes, it's 300 degrees. Yes, trust me when I say, once you've done this, you are going to enjoy plotting your function. Let's start by plotting that first one. That first one, it starts from 0, it ends at 360. So we will say sine starting from 0, at point 0, it gives us 0. And then we go and update and say at point, what? Our next critical point is 90. At 90, it gives us 1. And then at 180, let's see, at 180, it gives us 0. Remember, we're plotting two functions on the same set of axes. At 270, it gives us that -1. Definitely at 360, it will give us 0. So now let's see. We just connect the dots. Just connect the dots, and then from there we take it to 0. Yes, so can you see? So let's see if indeed that other one shifted by 30 units towards the left. So that means it must follow the exact pattern, the exact range, and everything must be exact, except that it's like when you look at it, it has been shifted towards the left by 30 units. So let's see, we will therefore say sine into the first point is -30, where we need to start. Remember, they said -32, 330. And then you plus it by 30, you say equals to, it gives us 0. So that means at where it is -30, it is 0. I've put a dot there. Then you just go and now you start editing. You follow those critical points. If you remember, the next one was 60. So that means is it 60? I would like to believe it is 60. And let's see. Let us see. Yes, it is 60. So let's put 60 there. What does it give us? It seems to be giving us 1. I'm not sure if you punch it, it gives you 1. But this is what it is giving me. Okay, and then now we go and edit it to the next critical thing. I think it was 150. Critical one, it was 150. Then at 150, it gives 0. Then we go back and we do the next critical. It is 240. At 240, it gives -1, which is somewhere there. And then the last one, it is, what is it? 330. Let's see. 330, it gives 0. So can you see? And then all that you have to do is just to connect the dots. Connect, just to do that at 0 there, and then it does that. At 0 there, and then it does that at there. So can you see, the honorable member? It's like the original graph has indeed been shifted by 30 units to the left, because from 0 to there, it is a shift of 30 degrees. From there to there, a shift by 30. So every point has been shifted towards the left by 30 degrees. the difference is 30 degrees. So can you see, that's what we mean when we say it is exactly the same function of sine. It's just that that function of sine, now we have just shifted it by 30 units. For you to know whether towards the left or towards the right, that's when you perform that calculation. So I hope that part makes sense, the honorable member. Maybe let's try and plot again a different function. Maybe this time around, let's do the one for cos. So I may not go into detail or step by step, just like I've done. Looks like that information has disappeared. Okay, I will just, let's see, find a blank page. Okay, then it's fine. I will just use this blank page. So I was saying, let's now plot another one. Which one can we plot? Maybe let's plot y equals cos x, nay, whereby x is the element of, for this one, let's start from 0 degrees and go all the way up to 360 degrees. Nay, let's plot another one. Let's plot another one of that same mother graph, but this time around we are going to shift it. Let's shift it by maybe that. And then as we plot this one, we'll say x is the element of, okay, let's start from 60 degrees, and then we will go all the way up to, let's go up to 420 degrees. Yes, let's go up to 420 degrees. Very, very much important, the honorable member, that as you work out this type of a function, this time around, let me just say you will be having a Cartesian plane like that. Yes, and then let me see, we are having one there, negative one there. This is the y axis. We are having one there, and then negative one there. Obviously, that one is 0 over there. Okay, and what else? In terms of the critical points for that one, of course, x, because that one, it hasn't shifted. It means we're going to start from 0. Definitely, it will be the period being 360 that you divide it by 4 to get the critical points. So that means those critical points for that one, it would therefore be, let's see, it would be, let's say 90 there, 180 there. Nope, that is too much. Let me just create enough space for that, for the, okay, let's say 90 there, 180 there, 270 there, 560 there, let's see. And 150 there. Yes, so that means we'll have 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So this would be the critical points for that function at the top. Name. So now, let's say you were not only doing that one at the top, but you are doing this one that has shifted. How did that shift? Let's see. It is x minus 60 equals to 0, x equals to 60 degrees. So that means it has shifted by 60 towards the right. Name. So now it is clear to say, okay, it is actually shifted by 60 towards the right. In other words, it doesn't start from 0, but it starts from 60. And for that reason, we do know very well that we are having that 30, 60 there, 90, whatever there, and then that there. Even though I may not be accurate, but you will definitely be given, what is this thing? What do we call this thing? The honorable member. You will be given that grid, the sheet which is having those grid lines. Then you'll be able to now space them equally. Okay, so now remember, we say it has to start from 60 because it has shifted by 60 degrees to the right. So that means now to find the critical points for the next point, it will be 60 that you plus it by that critical value. It now moves from 60 to 150 degrees. You plus it by that same 90, it goes to 240 degrees. You plus it by 60, takes you to 330 degrees, plus it by another 60, and not 60, but 90. Then it takes you to, is it 420? Yes. Yes, it takes you to that one of 420 there. So these are the critical points that you need, the honorable member. So definitely, if you have to plot that one of cos x, I think that one is an easy one. By now we know that it will definitely take that type of a shape where it goes from 0 at 1 and then it goes there, negative that, and then it goes back to 0. And then from there, it goes back to that 60 there. So in other words, it does something like that, and it does that, and then it does that. Yes, something of that nature. And then this one that has shifted, it will therefore mean it shifts by 60. So that means each point shifts by 60 to the right. It starts from there. Can you see? And then from there, it will go to that next critical point, and then it goes to that next critical point, and then where does it go? It goes to that next critical point, and then from there, it ends at that last critical point. So now you just do exactly just like you did, but this time around, you are having that, now doing that, even though my drawing, maybe, yes, can you see? So now you just need to remember to label them. You say, this is that one of y, which is equals to cos of x minus 60. So even with the previous drawings, we had to label them because we are having two types of function. This one is the one of y equals to cos of x. Yes. Can you see that each point, it has indeed shifted by 60 units? The range is still the same. The shape, it is still the same. So that means it is still exactly the same thing. It is just that it has shifted by that. So in other words, if you did not have to plot that function, nay, that means what gets to be removed there, it is just that sketch of that function. That's all that gets to be removed. Everything else, it stays as it is. So that means you would still have to now find the critical point, that critical point which you know that depending on the type of a function, it would be 360 divided by 4, and then it gives you 90. Can you see? So if you know, if it didn't shift, we would know that from 0 degrees, we just keep on finding the next critical point by adding by 90. Can you see? But now, with regards to the one that has shifted, it no longer starts from 0, but you say, starting from that point where it shifted, you then add that critical value from that point where it has shifted. And that's how it will then jump to take you to those other important points. And those are the points that are critical because it is those points that you use in order to put the dots where you know that, okay, these are the dots that I'm going to be connecting. Very much important, the honorable member there. I believe all that I've explained up to this point it does make sense. Maybe let me add one more. I will also have to try and be quick on this one. So let's just say now you are just plotting this one of y equals to sine, let's say that 30, let's just shift it. And this one, let's see. For this one, let us just plot it up to this point of negative 180 degrees and all the way up to 180 degrees. Okay. I will definitely not waste time on this one, but I will say the shift on this one, remember, if you have to calculate the shift, it is that that minus 0 degrees you equate it to 0, and then that means x is equals to positive 30. So that means it has shifted by 30 units towards the right because the answer there is positive. So let's now do our Cartesian plane. Then when it comes to our Cartesian plane, you can just do something of that nature because the left-hand side and the right-hand side equal, and then you can just split it in the middle like that, where you will therefore say, okay, this is my value of 1, like the value of 1. Okay, and definitely that one there being the origin. So this is now what you need to do. What is your critical point? Originally, it would be 360 divided by the period of that, which is what? No, the critical point being the period divided by 4, it gives you 90. So it spaces by 90. To move to the next critical point, you jump by 90. But this function, it shifts and it starts at 30. So that means if this is where you are having your 90 there, maybe let me not. Let's say if this is where you are having your 90 there, and then your 180 would be there, and then this would be your negative 90, this would be your negative 180. So can you see? And we obviously know that we will be having that 30 there, and then after 30, it would be 60 there, and then 90, 120, 150, and then that, negative 30, negative that, negative that, negative that, until we get to that. So can you see this one? It starts at that point of 30. So that's where it is therefore going to start. And then it no longer starts at 0, but it starts at 30. So if it starts at 30, what will be the next critical point? That's what I meant when I was saying 30, you jump by 90. Then you get to 120. 120 degrees being that one there. And then you need to jump again by 90. It gives you 210. You won't need to go to 210 because they said as you draw it, you must end at 180. So that being 180 degrees. Remember that is 90 there. Where is that negative 90? Negative 90 is that one there. And then negative 180, it is that one there. So that is a restriction. You say you just need to enter there. So if this is 1, for example, this is negative 1, maybe that would be half, that would be negative half. Doesn't really matter that much. Okay, so now let's find the critical points on the other side. Remember, it is 30, and then you jump by 90 units to the other side. So that means if you want to find that, a smart learner would just subtract it by 90 so that you know what is the critical point on the left side. That is why you end up having that, and then continue to space it by 90, but in that direction, and then you end up getting negative 150. You don't end there. If you continue again, it takes you to negative 240, but you can't go there because the restriction says start from there and then end there. So that is why I don't need to worry about those values after that restriction there. So then it's fine. Now it is that time where we can start plotting. So let's see. They said from negative 180, I like plotting from left to right. So that means you will say sine negative 180 minus 30. It gives us a half. So half, it would be that one there, somewhere there. Now this is that half, remember, and this is the negative half. Can you see? Okay, then we go to the next critical point, being that one of negative 150. The one for negative 150, it gives us 0. Then the next critical point is that one of negative 60. Negative 60, it gives us negative 1, and then you put there. So that means you only concentrate on the critical points, not the one of 90, 180. No, those ones, you just used them to be able to space your things correctly there. Then you go to your next critical point. It is not 0, but it is that one of 30. So can you see, very much important that I'm having those different colors there so that I know which ones are the critical points, the ones in blue. Then I go to 120 now. 120 minus 30, and then it gives me 1. So it is that one up there. Okay, from there I go to the next one. Okay, I can't go to the next critical point, but I'll have to go to that one of 180 because they said I must include that 180. And it gives me half, but a positive half. And that's why I'll put a dot there. So in plotting these, it definitely looks like all that I have to do is just to connect the doors, just to connect the doors, just to connect the doors. Yes, something of that nature, the honorable member. This is that function of y, which is equals to sine of x minus 30 degrees. Not that much complicated, but trust me when I say you will definitely need to practice on how you work it out. You'll have to do as many times as possible, the honorable members, many times as possible, so that at least you've got an idea of how it works. I will try find some exercises that you can use in order to train yourself or test yourself if you understand how to plot this type of functions which have shifted. What else did I want to include? I think I've covered everything, the honorable member. I think I've covered everything because this is based on what you must be already knowing, the honorable member. It is actually based on that. The most important part is for you to be able to calculate the shift so that you know where it starts. And then in terms of the next critical points, you just use what we have already learned on how to calculate the critical points, because that part, it helps us to know the spacing so that we know from this point, we jump onto this point. From this point, we jump onto this point. Very much important there. I think I'll just leave it here, the honorable member, and say until we meet again.